Okay, let's go.
So today we're going to talk about what it takes to rebuild a 1937 Bugatti Type 57 C, the C meaning compressor, engine. And I'm Kent Van Oort with Joyride Pictures with
Jim Stranberg from Stranberg Vintage Auto, and we hope to show you what's involved in putting one of these engines together. So what we're looking at right now is the crankcase, which is the upper part here, and the sump, which is just on there temporarily at the moment. And it has, in the gear in the rear there, drives off of the crankshaft and will drive another gear which goes up to a tower to drive both camshafts. This is a twin cam engine, 3.3 liters. And somewhere around 150 to 170 horsepower. So what I've done is I've put on a side plate here onto the cylinder block, which behind that plate is the water jacket for the cylinders. I'm trying to seal the cylinder block such that I can do a water test on the block to make sure there isn't any leakage either from the top of the block or coming from these holes. As you can see, 3 of them, there is a tube that goes down and comes out in the bottom here. That drains the oil from the cam box down through the water jacket into the sump. Now the idea is to test those tubes to make sure that they don't leak. This is the upper manifold, water manifold, to which I'll attach a tube and fill it with water. Fill the whole block, not where the cylinders are, but on the water jackets. Fill that all with water and then pressurize it to about 10 pounds in that to make sure that there's nothing leaking. So I did the water test with air pressure, as I mentioned, and I found a small leak in one of the tubes that drained the oil back down into the sump was leaking, and obviously then the water would go into the oil and into the sump, which is not a good idea. So I've set it up in this little bench mill that I have, and I'm about to drill those tubes out. There's 6 of them, and I have to drill along the top and then turn the block over and drill them out from the bottom, getting the tubes out of there, of which then I'll come back and replace it with a copper tube. So this is the beginning of that process. And it's a lengthy process, but that's the way it is with building a Bugatti engine. So as you can see, this was the bad tube. It had the hole in it. The other tubes didn't have holes in them at this point, but they all been into the block with the same length of time as this one. Therefore, I'm sure that at some point in the near future, they would have a hole also. therefore it would seem reasonable at this point to take and replace all the tubes, not just replace the one that was leaking. So the point now is I've got the old tubes out. I go back into the hole with a tapered reamer and I ream the hole so that it has a taper such that when I put the new copper tubing in, I can then swedge that out against the wall of the block and then insert a tapered pin that has been drilled in the middle of it to allow the oil to go through. But the taper pin actually helps swedge that copper out against the wall of the tapered hole there in the block. Okay, at this point I'm ready to start with putting the copper tubes in. I've got the holes all drilled. I've got them all reamed with a taper reamer, so they're ready to accept the new copper tubing. And I cut the copper tubing to a little longer than what I need, because I can always shorten it. And I take and heat it up and anneal it so that it's softer and will bend easier, because it's very difficult to get this bend just right. I'm putting these copper tubes back into the block because it has to change directions. It isn't just a straight shot down to the block. It has to come down and come out. It's sort of analogous to either putting toothpaste back in a tube or shoving a snake up a wildcat's ass. So that's the whole reason for this and being rounded and everything. By putting this in and pounding it out, I'm swedging that copper out against the tapered hole that I put in here. This is what the pin starts out, and I first of all part it off, and then secondly drill a center with a center drill, and then go through all the way with another drill. And because I'm holding it in this thing here, this runs fairly true. You can hold it in here and then squeeze here, and you've got this tight. It runs fairly true through this taper pin. Then I clean it up a bit and put some sleeve retainer on it, and then jam it down into the oil return line. So what I'm doing here is, these are the main bearings, and the caps, and it held on. There's this long stud goes on, and a castellated nut fit on top of that. Now what I've done, and the reason for doing it, is I've safety wired not only the stud, but I've safety wired the castle nut onto the stud. The reason for using safety wire, if you think about it, if you just use a cotter pin, that'll hold the nut to the stud, but there's nothing to hold the stud in the crankcase. So therefore, if I safety wire both the stud and the nut, then I've locked the two together and have also locked the stud into the crankcase. So that's the reason for going through all this trouble. A lot of people just put cotter pins in here. That doesn't really hold the stud. It holds the nut onto the stud, but doesn't hold the stud into the crankcase, which is aluminum. And with the heat, there's always a lot of expansion and contraction. Therefore, these can actually loosen up. So with the safety wire on there, it's on there, it won't come loose, and everything is safe and go on to run your engine. So this is the flywheel, and usually my next step is to put the flywheel, mount that onto the crankshaft. And to do that, you have to put that on before you put the sump back onto the crankcase, because otherwise you can't come in from behind with the screws. And also, if you'll notice, this hole here is for the pilot bearing, and there's a ledge here. You can't go this way with the pilot bearing. It has to come from the back side. So you need to take care of that before you put the flywheel onto the crankshaft. There you see the hole that's it's countersunk. It also has this little slot in it, and this is where the screw will go through to hold the flywheel onto the crankshaft. And this is the bolt or screw. I call it a screw because it's slotted, it's not a hexagon. But it has a little key in the bolt itself. I usually take a drill bit of some sort, so it's a hardened piece of steel, cut it off and put it in with Loctite and set it in there. But that goes into that slot in the crankshaft and keeps the bolt from turning when you're trying to put that back, put the flywheel on and lock it down. So in doing that, because the flywheel fits on the end of the crankshaft very tightly, the little flange there. So I put a couple on here and then go to the other end because it gets cocked a little bit and sort of bring it on, and then do like every other one and tighten it down. That brings the flywheel up onto the crankshaft. And then each one of these nuts is, I use a torque wrench on them so that I get them all even, and then cotter pin them. Again, now you can cotter pin a nut to a bolt and it'll stay. It's not like cotter pinning a nut to a stud. So that's the reason why we do cotter pins here. We do safety wire on the main bearings. I'm putting the rings on the pistons, and from there I'll go and put the rods and pistons in the engine. But these are original style pistons, made in France. A couple things that are different from, say, today's pistons. This has 4 lands, so in other words 4 rings. Normally today pistons would have maybe only 3 rings per piston. The other thing is the piston itself is reinforced by steel plates inside the piston. That makes it so that you can run these pistons reasonably tight in the cylinder, reasonably tight being, say, 3,000ths clearance. Where some pistons today, especially in the racing applications, you want at least 5 or 6,000ths clearance. So they don't expand that much once because of the steel plates. Downside being is that it makes the piston that much heavier. But in a slow revving engine or a low revving engine like this, top revs would be somewhere around 5,000 RPM. It's not bad. It's better that you control it by being able to put it in at a close tolerance You don't get the piston knock at the startup when it's cold. And it lasts longer. It works really well. Okay, so what I'm pointing out here is these are the original rods. Originally, the rods had a poured bearing or babbitt. The rod is set up in a special mold. The babbitt is poured into the rod. Once it comes out, then it has to go onto another machine where it is machined till you get a very fine, smooth surface to the right size or the right diameter of the crankshaft. So that's what you see in here. It's not like the modern bearings where you can just buy them off the shelf, snap them into the rod and be done with it. These have to be, the rod has to be cleaned. The bearing or the babbitt is poured into the rod. You then set it up on a special machine that'll come in and do a very fine machining of the bearing surface here, giving you the right clearance that you want for between the rod and the crankshaft. What I'm doing now is I've got the pistons, I have the rings on the pistons, I have the rods, they've been all cleaned and everything's ready to go there. Just one little side note, all of these parts, the crankshaft, the pistons and the rods, the flywheel and the clutch, have all been balanced. And you get a much, much smoother running engine by doing that. It's extra time, it's extra money, but it's worth the effort. Because it really makes the engine run so much smoother. So what we're doing now, I've taken the crankcase and I've turned it upside down. The crankshaft's at the top and this is the bottom. I hang the rods down through the crankcase and put the pistons on. And the next step will be I'll have all the pistons on and they're just hanging there. Then I take the block and I come from underneath and bring the block up to the pistons and then insert the pistons into the block. Then as I bring the block up to the crankcase, up to these studs, I can then attach the rods to the crankshaft as we go along. It's a lot easier to do it that way than it is to have the rods and the pistons on the top and you come down with the block, because you can do the first 6 fairly easy. But the last 2 will get you every time. Here we are. The rod has been brought up to the journal on the crankshaft. Now take the cap, put it down over the rod bolts. And I've usually put the bolt in after I have the rod up to the crank journal, therefore not taking the chance of scratching the journal at all. Then we put the nut on, bring it down, torque it together, and then use a cotter pin to hold the nut on. We've got the sump on now. The lower part of the engine is pretty well closed up. So back to the top again. This is the tower, the gear tower. In here there's a big gear. That gear meshes with the gear that was being driven by the crankshaft. It then comes up here and the camshafts live in these pockets here going across. And they have gears that will be fed off of this gear here. So what I'll do is I'll find out if I have any clearance, because a couple of these are new gears and I don't know if they still have any gear lash. If they don't, between the crankcase here and the cover here, I'll have to make a shim and put the shims in there to raise this up to give me what I want as far as gear lash goes.
Should we talk a little bit about this intake manifold that the supercharger is going to be attached to?
Yeah, we could do that too. So here I'm fitting up the intake manifold. Now this particular manifold was never on this engine. And the reason being is we're putting a later model supercharger on which takes this particular manifold. So it's very critical to put it on and make sure that it fits tight. Obviously, if it doesn't fit tight and there's air leaks, nothing's going to run right. So in doing so, what I found is this manifold, there's underneath here on the water plate that goes across there, was hitting on those little screws that were going there. So I had to go in and instead of leaving the curve like that, I chamfered it and flattened it out a bit, giving it some clearance underneath so that the manifold will fit up to the block nice and tight, and obviously making a airtight seal here. This particular supercharger is not the original supercharger, or original, I should say, not type. But what I'm getting at is this supercharger came off a later model car. It's a little longer, produces a little more power, but the other interesting thing about it is that it's a downdraft supercharger. And what I mean by that is that the carburetor sits such that it's a downdraft Weber carburetor, as opposed to on a regular supercharger or compressor for Type 57, it would be an updraft Stranberg carburetor. So the downdraft works better, better breathing, easier to get the fuel into the supercharger to the engine. So as you can see, the gasket goes on reasonably easy, and it has to be mounted like that. You have to do the whole thing at once. So you put the manifold and the supercharger on together, because underneath, when you got this on, underneath there's a whole line of nuts also, and you can't get to them once it's all there. Now, it's mounted to the engine, so what I'm doing, I'm testing it right now to make sure that the two drives, the drive here coming out of the engine and the drive coming out of the supercharger, line up perfectly in line, so that when they're running, they run as one shaft.
So I guess at this point now we've got the intake manifold, the superchargers on, and now you're going to start working on the...
The first thing we need to do is put the cam boxes on, put the camshafts in, and check to see the gear lash. You know, I talked about the gear lash before on the other bigger gears. Now you got the cam gears, and they have to mesh with that one big gear that's in this cam tower. If I don't have any gear lash, then I have to lift the cam box up. This wing here that's it, that's where it's going to live. But I can lift the cam box up by putting shims underneath the cam box, between the block and the cam. That'll lift that up. So I always start from the back. Sometimes you can't get it down far enough to start on number 8, but I start on 7 or 6. And then I move forward with the cam and bringing it down into the cam box. Once I got that all settled, then I can come back and start doing the valve adjustment. Since it's in the picture, these little caps here are what I call a lash cap, and they fit over the top of the valve. And it's the cap, the lash cap, that you change the thickness of the cap to get the clearance you want on the camshaft.
And I think we have a picture of you measuring those.
Right, here I am. Yeah. I have a real quick micrometer, and so this is the cap, I just put it on there and let that go up, and it'll tell me how thick that cap is. If it's too thick, I'll put it in the lathe, and because these are all hard, I'll take a very little bit off at a time, measure it again, and put it all back together again. So I think the next step was to go into the shop, and
Yeah, let's go into U.S. Automotive Machine.
here we are.
So yeah, here's the assembled motor on the dyno, ready to go.
Dyno is set up such that you can run the engine and put a load on it. Just running the engine up without a load on it can be somewhat damaging to the engine. It'll put a load on the engine, and things like the valves and the rings and everything will start to seat in like they're supposed to. We can check it and see how much horsepower we're getting at a particular RPM. If nothing else, it gives you bragging rights, but it's really nice to know. So here's the initial start, adjusting the magneto. The idea is to have the magneto so you can turn it a little bit till you get it started, and then you do the fine setting of the magneto with the timing light once the engine is running. Then I can take my timing light and I can check that with my top dead center mark that I've put on there and see what the advance is on the firing of the spark plug. And I change that until I get it just where I want it, and then there's a couple nuts underneath it. I tighten those down and the magneto stays in. Lock it in place.
So I think at this point we just drop the music out of the video, and we just let our viewers just listen to that engine purr on the engine dyno.
Okay, let's go.
I just want to say thanks, Jim, for allowing me to be a fly on the wall to see the progression of the engine build. It was fascinating to me. I learned a lot in the process, and I think our viewers will like it.
Yeah.
I think this is the only video of its kind out there. I don't think anybody else has ever really documented what it takes to build a old Bugatti motor that's been sitting idle for years and has found a new purpose in life and is going to come back to life.
Well, thanks, Kent. It's been good to have you around, especially with the help when I needed an extra set of hands, which obviously when these things are so big, it comes in very handy. But it's been enjoyable, and I hope people will enjoy this. It's a fun project. That's about it.
Yeah.